Okay, here's the rest of the answers to the problems. So back to number 10, I had forgotten to put this 280 into the problem, so now it's there. So you're looking at Mary Kate on the airplane. She's traveling 381 miles, and then another 280 miles. And then her total distance is 661 miles. And then her total time is 58. The 3 hours where she stopped, got to convert that into minutes if you're going to add it to the other 2 times, and then 55.2 minutes. So her, and that 55.2 came from calculating the 304 miles per hour. That's the speed she was traveling from Buffalo to Philadelphia. So I had to use this time equation, distance over speed. So 304 miles per hour for 280 miles gives us the 55.2 minutes. It actually gives you an answer in hours. You have to divide that to get minutes. So total time ends up being 293.2 minutes. So when you divide those, you get 2.25 miles per minute. All right, number 11. So moving on to part 2. Zach's pacing in his room. He's watching the Cowboys. So I drew out his path here. He went 5 feet to the right, 6 feet to the left. So he goes a foot beyond where he started, and then back 3 feet. Back 3 feet to the right. So if he ended here, 1 foot past where his starting point was. So there's 1 foot, and then another 2 feet. So he ends up 2 feet to the right of where he started. So that's his displacement. The total distance that he walks is 14 feet. Number 12. Charlie, famous NASCAR driver, he's driving at 200 miles per hour. And he needs to figure out how long the track is, how many kilometers. If it takes him 14 minutes, I'm going to put that into hours so that it matches the time unit in my speed. 14 divided by 60 is 0.23. To solve for distance, you do 200 times the 0.23, speed times time. It's the end of 4th period. And then we get 46 miles. We have to convert that into kilometers. So we get 74.1 kilometers. And then it asks for his momentum. Momentum is mass times speed, mass times velocity. So you get 147,000 kilograms times miles per hour. Number 13. We have Bella. She's also in a race car. She goes 1,600 feet times 200 laps. So 320,000 feet total. We have to convert that into miles. So conversion from feet to miles. But her displacement ends up being 0. If she's traveling on a track and she starts and ends in the same spot, then she has a 0 displacement, even though she's actually moved for 60 miles. Number 14, so we're looking at the graph of the 2 football motions. They have the same speed because if you calculate the slope of those 2 lines, you get the same value. The only difference is that one is in an opposite direction. The blue line is in a negative direction. So they're throwing the football at the same speed, just in different directions. So they have opposite velocities. Lena, number 15, walking to the art store. So she goes 1 kilometer east, 1 kilometer south, another kilometer east. So her total distance traveled is 3 kilometers. If you were to calculate her displacement, you draw a straight line from where she started to where she ended. It doesn't actually ask you to calculate displacement, just draw the line for it. All right, number 16. Ms. Sikowski has joined us. She's here for lunch, but she's going to listen to us go through the last 4 problems together. Number 16, so Lily's working at Jurassic World. She goes 0.85 miles to the east. Then she goes another 0.35 kilometers to the west, so you have to calculate, or you have to convert that 1.2 kilometers into miles. And then you need to solve for her velocity. So you find her displacement. She's 0.35 miles to the east, or sorry, to the, what's left? West of where she started. So that's a negative direction. Divided by your time, 19 minutes, put that into hours, 0.32 hours, and you get negative, because she's in the negative direction from where she started, 109 miles per hour. All right, number 17, Jackie and Valerie, so they go around a track for 3 miles. So their total distance traveled is 3 miles, and it takes them 30 minutes. So that's 0.1 miles per minute, but their velocity ends up being 0 because they don't have any displacement if they're walking around a track, if they're starting and ending in the same spot. Number 18, Aiden with the robot. So his robot goes from 30 feet to the house to the mailbox, stops there, and then goes the 30 feet back. So 60 feet total traveled, and then if you add up his total time, you get 370 seconds. So you need to put that 3 minutes in the middle into seconds. Divide those out, and you get 0.16 feet per second. Velocity ends up 0 because the displacement is 0. So just like in the last one, if he's going from the house to the mailbox and back, he has no displacement. All right, number 19, Leanne's gonna have the greatest momentum because she's traveling in the car. So the car has the bigger mass, meaning she's gonna have the higher momentum. And then the last one, number 20, you need to use Pythagorean theorem on this one. So you have butterfly traveling south and then west. So if you're going to calculate the displacement that the butterfly travels, you have to find that hypotenuse of that triangle. I know you guys love your geometry. So to do that, Pythagorean theorem is a squared plus b squared. And you need to solve for c. So to do that, square your a and your b, and then take the square root of that. So you end up getting 2.8 kilometers per hour southwest. That's your velocity. All right, and there you go. There's all your 20 answers.